going to continue our statistics unit. We're going to look at something called normal distribution. But before we do that, let's look at the do now. It says a set of data has a mean of 15.2 and a standard deviation of 2.1. Find the range of numbers that lie within one standard deviation. Now remember, there were two methods that I showed in the previous lesson. So I'm going to do one of the methods for part A and the other method for part B. So the first method was the one with the line. So I'm just going to give myself a little bit more space here. So the first method was the one with the line. So you draw a line, and in the middle of the line you put your mean. Okay, so our mean was 15.2. Now you go one standard deviation away in the positive direction, and you have to go one standard deviation away in the negative direction. So to get from here to here, you have to add your standard deviation, which is 2.1. So we do 15.2 plus 2.1, and we get 17.3. Now to go in the opposite direction, we have to subtract 2.1. So we have 15.2 minus 2.1, and we get 13.1. Okay, so our range of values is from 13.1 to 17.3. Okay, now we're going to find a range of numbers that lie within two standard deviations. Now what you can do if you want to continue using the line is you would just go one further and again add 2.1 to get the next value, and here you would have to subtract 2.1. If you prefer that method, go for it, that's totally fine. But I want to show the other method as well. So the other method was you have the mean, and then you add and subtract. Here we're looking for two standard deviations away. So we're adding and subtracting two standard deviations. Okay, so the mean was 15.2. And we're adding and subtracting 2 times the standard deviation of 2.1. Now we have to do 2 times 2.1, which is 4.2. So here, I'm just going to bring the work up here. We have 15.2 plus or minus 4.2. So to get the actual range, we split this up into 15.2 minus 4.2 and 15.2 plus 4.2. So we go here, 15.2 minus 4.2 is 11. So this value here is 11. And then we have, 15.2 plus 4.2. And we get 19.4. So this here is our range within two standard deviations. Again, whichever method you use, both are correct and both are acceptable. Moving on. Okay, so many populations have a distribution that is called the normal distribution or the bell curve. Okay, so this normal distribution is going to be a key word for today. So this is a key word for today. So this curve, it shows the percent of a normally distributed data set. So again, this is going to be a key word, normally distributed, that lie a certain amount from the mean. So we're still using standard deviation and mean today, but it's in a normal distribution. So this is what our bell curve looks like. So it starts really small. The majority of our data is within this middle portion. And then again, it goes small at the end. Now, here is a new symbol for mean. And it again is a Greek letter, the letter of my people. It's a Greek M, so that represents mean. So it's kind of like a U with a long line in front, and then you write a U. So that is going to represent our mean. It is called a mu. So here's our mean. Here, this is the mean plus 1. That means 1 standard deviation. And the minus is -1 standard deviations. So then this would be 2 standard deviations. I'm just converting it to what we're used to. 2 standard deviations. And then we get to 3 standard deviations. So we haven't done that, but it's nothing different. You would just do the process one more time. Okay. Now, this information that's right here is extremely important. 68% of the data lies within 1 standard deviation. So from here to here is 68% of our data. Oh, I should have made that red to continue with the color scheme, so that's what I'm gonna do. So from here to here, within 1 standard deviation is 68% of our data. 95% of our data lies within 2 standard deviations. 95%. And lastly, 99.7% of our data are within 3 standard deviations. So 99.7%. So this is super important that you know these 3%. It's also called the empirical rule. So just keep that in mind. All right? And now, I'm going to move forward. So for a population that is normally distributed, keyword for all of our problems today, find the percentage of the population that lies within 1 standard deviation. This is from the slide before. 68% of our data lies within 1 standard deviation. Within 2 standard deviations, it's 95%. Within 3 standard deviations, it's 99.7%. And now this says more than 3 standard deviations away from the mean. We kind of have to do a little bit of work here. So I'm going to go back for a second. If this is 3 standard deviations away from the mean, more than 3 is like these 2 little corners over here, okay? So what we have to do to find that is we know that the biggest you can have is 100%, right? Now, if 99.7% of the data is within 3 standard deviations, there's not much that's going to be more than 3. So to find more than 3, you have your 100%, and you have to subtract that 99.7% to find what's that extra space that I colored in green. Now, when you do that, we can't type percents in our calculator. We're just going to do 100 minus 99.7, and you get 0.3. So 0.3% of our data is more than 3 standard deviations away. Okay, so moving on. A normal distribution has a mean of 12 and a standard deviation of 2. A super, super important key word here is that it says normal distribution. I said that's going to be our key word for today. Now it's asking for percent of values between these ranges. Now we don't know what our range looks like yet, so let's figure it out. Now I'm going to use the line method for this one. If you want to use the other one, by all means you can. So we start with our line, In the middle goes our mean. So now I'll call it mu, or the x bar, whichever you want. All means the same thing, is 12. So 12 is going to go in the middle. Now there's a standard deviation of 2. So to get one standard deviation away, we have to add 2. So we get 14. To get negative 1 standard deviations away, we have to subtract 2, and we get 10. Now, look, I don't have to go any further for part A. It says 10 to 14. That's within 1 standard deviation. Since it's a normal distribution, this is 1 standard deviation away, which means 68% of our values are between 10 and 14. All right, let's continue to see if we can find the rest. So 1 more away, which would be 2 standard deviations. 14 plus 2 is 16. So minus 2 standard deviations away. 10 minus 2 is 8. So now I have 8 to 16, which is part B. So that's 2 standard deviations. In a normal distribution curve, that is 95%. Now the next question asks for 12 to 14. We actually do have that, and that is right here, okay? I didn't mean to box 10 to 14, but that is right here from 12 to 14. Now this is where, again, we have to do a little bit of work. So if we look here, we know that from that one full 10 to 14, that was 68%. This is half of 1 standard deviation. So this is half of 1 standard deviation. That means this is going to be half of 68. Half of 68%. So to find half of 68%, you just divide it by 2. So we have 68, don't type in a percent, divided by 2, and we get 34. So this is 34%. So we did have to do a little bit of work there. Now, let's look at the last one. It says less than 8. So again, a little bit of work needs to be done. So here is our value 8. It has to do with the 2 standard deviations. However, if we wanted the values less than 8, we're not going to be finding half of 95. That's not going to help us. What we do have to do, though, I'm going to draw a little sample curve here, talk about it a little bit more. So let's say this was our 2 standard deviation mark, okay? And we know that was 95%. Outside of that 95%, so this here and this here, that's going to give us a total of 5% left within this and this, because we can only have 100%. So we have 5% on both of these sides. Now, normal distribution is even on both sides, so they're equal. So we would have to do that 5%, so the 5% left, and we would have to divide it by 2 to see what's left. 5 divided by 2 is 2.5%. So that means that this will be 2.5 and this will be 2.5. Okay, because that's what's outside that 95% interval. So less than 8 is this 2.5%. Because this would be our 0.8 on our chart, and less than that was the 2.5. Okay, let's move on. The scores of the critical reading portion of the tests in 2013 SAT are normally distributed. That's our key word, with a mean of 496 and a standard deviation of 115. What interval is within 1 standard deviation of the mean. You can use whichever method you like, okay? I'm going to use the plus or minus method since I used the line method in the previous problem. So within 1 standard deviation, we have the mean. Now you can use either the x bar or the mu. Plus or minus, we need 1 standard deviation. So our mean, we said, was 496 plus or minus 1 times 115 is just going to give us 115. Now this is an interval. It is, but I do want to write it out. So we have 496. Nope, that's not what I want to do. To get our interval, we do 496 minus the 115, and then we do 496 plus 115. Go to our calculator. 496 minus 115 is 381. 496 plus 115 is 611. So that is our interval. Again, if you want to use the line method, that's totally fine. So second problem, mean plus or minus. Now we're looking for 2 standard deviations. So it's 2 standard deviations. 496 plus or minus 2 times 115. You should simplify 2 times 115 before doing anything. And we get 230. So 496 plus or minus 230. I'm going to bring this up here. So to get the interval, we do 296 minus 230. And we do 496 plus 230. So 496 minus 230 gives us 266. And 496 plus 230 gives us 726. So this is our interval. Now it says, for part C, what percentage of students fall outside 2 standard deviations of the mean? Since this is a normal distribution curve, I'm going to draw it again. You don't have to if you don't want to. Now, 2 standard deviations of the mean, we have to remember, is 95%. That's within 2 standard deviations. Okay? We're looking for what lies outside of it. So in this space here. If in the middle, this not shaded area is 95%, what's left, the most we can get is 100%, is 5%. To get that, you would do 100% minus 95%, and that gives you 5%. So 5% falls outside 2 standard deviations of the mean. Level of confidence. So in normal distribution, we can consider a data point to be unusual or unfair if it is more than 2 standard deviations away from the mean. Now we call this the 95% level of confidence because within 2 standard deviations, that's 95% of your data. So if it lies outside that data, we say that it is unusual or unfair. So let's look at the steps on how to find it. You find the interval, that is 2 standard deviations away from the mean. So when we do this, I suggest using the line method where you have the mean in the middle, and then you go your 2 standard deviations away. So 1 standard deviation, -1 standard deviation, 2 standard deviations, and a -2 standard deviations. Okay, so you find this interval. Now, you determine if your data point is within that interval. So if it's in this range. If it is not in the interval, you conclude that it is unfair or unusual because it's outside the 95%. So let's look at a question. It says, Elizabeth waited for 6 minutes at a drive-thru at her favorite fast food restaurant. The last time she visited, she was upset with having to wait so long and notified the manager. Her name should be Karen in this case then. Just going to change that. So, I'm kidding. Just a joke. So, the manager assured her that her experience was very unusual and that it would not happen again. A study of customers commissioned by the restaurant found that the normal distribution, super important keyword, of the results. The mean wait time was 226 and the standard deviation was 38 seconds. Given this data and using the 95% level of confidence, was her time unusual? I know a lot is going on there. There's a lot of words, but we have to use the 95% level of confidence, so that means we need to make our little line here. So in the middle goes our mean, and our mean was 226 seconds. Now let's go 1 standard deviation away. So to get from here to here, we have to add 38. So 226 plus 38 gives us 264. In the other direction, -1 standard deviations away, we have to subtract 38. So 226 minus 38 is 188. Okay, let's go one more over. So 2 standard deviations away, that's our 95% confidence interval. Add another 38. So 264 plus 38 is 302. And in the negative direction, we have to again subtract 38. So 188 minus 38, and that's 150. Okay, so we found our range. Our range is from, so I'm going to write our 95% confidence interval is from 150, it's in seconds, so seconds, to 302 seconds. Let's see if Elizabeth's data point is within that range. Now, they told us she waited for 6 minutes. Our data is in seconds. So we need to convert 6 minutes to seconds. So I'm going to do that over here. So 6 minutes. To change this to seconds, you have to multiply 6 times 60 because there's 60 seconds in a minute. 6 times 60 will give you 120 seconds. Oh, I'm sorry. No, it will not give you 120 seconds. What am I thinking? It'll give you 360 seconds. Okay, so Elizabeth waited. So she waited 360 seconds. So 360 seconds is not in this interval. So this is not an interval. So since it is not in the 95% confidence interval, Elizabeth's wait time was unusual. So that's what we're going to write. So since 360 seconds is not in the 95% confidence interval, Elizabeth's wait time was unusual. Okay. All right. So let's do one more problem. It says the scores on the math portion of a 2003 SAT are normally distributed, super important, with a mean of 420 and a standard deviation of 122. What interval is within one standard deviation of the mean? What percent lies within that data? So we can use the line, we can use the other method, up to you. Let's use the line here. So in the middle goes the mean, which is 420. Let's go one standard deviation away. So to get one standard deviation away, we have to add 122. So 420 plus 122 is 542. 420 minus 122 is 298. So within one standard deviation, our interval is 298 to 542. And since it's one standard deviation away and it is normally distributed, that is 68% of our data. So now it says what interval lies within two standard deviations. Let's find out. So the mean is in the middle. We already found the first one, which was 542 and 298. Let's go one more. So to get to the next point, we have to add 122, and we get 664. And to get to negative 2 standard deviations, we have to subtract 122, and we get 176. So our range for 2 standard deviations is 176 to 664. Since it is 2 standard deviations away, that is 95% of our data. John Doe received a 750 on the math portion of the SAT that year. Is his score unusual? So we have to use the 95% confidence interval here. Our 95% confidence interval we found was 176 to 664. 750 is not in that interval. So 750 is not in interval. Well, I'll say not in confidence interval. So not in confidence interval. Since it is not in the confidence interval, it is unusual. So since 750 is not in 95% confidence interval, it is unusual. Doesn't mean it's bad, just unusual. Okay, so here is your check for understanding for this lesson. Complete this on a separate sheet of paper and upload it to Google Classroom. Have a great day, guys.